Hello dear student, I am Mondur Islam. Today in this video we are going to discuss an important question from CSIRNET June 2021. Okay, this question from part C. This question from part C and question ID is 511. Okay, this question from real analysis. The question is if A is a subset R and f is a function from R to R is constant function. Okay, then there are four options given. We are going to verify each option one by one. First one says if A is closed, then f is closed. Is true. See, for option 1. Okay, for option 1 I'm choosing A to be R. Let A equal to R. We all know R set of real number is both closed open. Okay, it is closed as well as open also. Closed as well as open also. Okay, so in this case I need closed. It says A is closed. Okay, so I need closed. So R is closed. So I take equal to R. Now if I choose the function f from R to R by f is equal to tan inverse x. Okay, x belongs to R. If I choose the function f is equal to tan inverse x, then we all know range of tan inverse x is this closed. R is closed. Okay, range of this function tan inverse x. What is this range? The range of this function range f equal to minus 5 open minus 5 to 5/2. Okay, so if you compute fa, so this gives minus open 5/2 5/2, right? See see A is closed. Okay, but this is open interval, so it is open set, open in R. Okay, but option 1 said if A is closed then f is closed, but in this case A is closed, A is R is closed, but if A is open minus 5 to 5 interval, so it is open set, it is not closed set. Okay, it is not closed set, it is a open set, so it this is one contradict option 1, so option 1 is incorrect. Now option 2, it says A is bounded, then f inverse A is bounded. Okay, for option 2, see option 2 I am choosing constant function. Okay, f from R to R by f is equal to constant function, suppose 1, constant is 1, constant value. If I choose this function, okay, then what is the range? The range of this function, range means possible value, it will be single set 1. Okay, single set 1. Okay, assume this single set is A. Okay, A is A. If you choose a single set is A, then it says in option A is bounded. Okay, the single set is bounded, it is obviously bounded, this set is bounded. Okay, so if you want to write like this, range means f of R because the domain is R. Okay, so f of R is nothing but A, and A is single set 1. Okay, so in this case R equal to f inverse A. Okay, see in this case A is bounded. Okay, because single set 1 is always bounded, but R is bounded, R is in unknown interval, minus, you can write like this, minus infinity open interval. Okay, so it is not bounded. Okay, so option 2 is also incorrect. So option 2 is also incorrect. Now option 3, it said if A is close bounded then f is compact. We all know a close bounded subset R is compact. Okay, this close bounded imply this compact. Okay, close bounded imply compact. Then we all know, but f is given continuous. We all know continuous image of complex compact, so f is nothing but the continuous image of a complex set. Okay, it is compact, and f is continuous, so continuous image of complex set is compact, and every complex set is close bounded, so this option is right. Okay, are you getting my point? For option 3 I am saying that it is given that for option 3 it is given that A is close bounded. Okay, A is close bounded, it is given that A is close and bounded, obviously subset R. Okay, this is subset R and close bounded. We all know close bounded subset are compact by Heisenberg theorem. Then A is compact, I can write A is compact. Okay, but if is continuous, it is given that f is continuous, f one continuous function. So we all know that continuous if is compact set is compact. So this implies fa is compact. Okay, since f is continuous, so fa is compact. But we all know compact subset are close bounded. Compact even compact subset are close and bounded. So it implies closed and bounded also. Okay, so this is option 3. So option 3 is correct. Now option 4. For option 4 I am giving a short proof. Okay, it says A is bounded, then f is bounded. Okay, for this I am give a short proof, and it is by condition method. See, option 4 says this: if A is bounded, then it says fa image of A will also bounded. Okay, and this is true statement. This statement is true. Okay, I am going to prove this. Suppose let A is bounded. I assume that A is bounded. Okay, and further I assume if possible let we have to prove f bounded. Okay, so I'm going to contact method. So I'm choosing f is unbounded because I'm proving in condition. So I assume the reverse. Okay, if possible let f is unbounded. If f is unbounded, then we can always write there is a sequence xn. Okay, in A n greater than 1. There is a sequence xn in A such that we can write like this: f of xn can be made greater than n for all n belongs to natural numbers. Okay, this always happen because if xn if is unbounded, then always get such a sequence such that f xn greater than n. Okay, f xn greater than n for n belongs to natural number. Name it 1. Okay, now see, xn belongs to A, it is given that A is bounded, this set is bounded. See, this sequence in A inside this set, in this set is bounded, so it implies the sequence is bounded. It implies the sequence xn is going to be bounded. Okay, but we all know bounded, this sequence is bounded. Okay, this is a bounded sequence of real number. Bounded sequence of real number. We all know every bounded sequence of R has at least one convergent subsequence. Okay, every bounded sequence in R has at least one convergent subsequence by Boltzmann's theorem. So from here you can write there is a subsequence xn k. There is a subsequence xn k of xn. You get a subsequence. You always get at least one subsequence. Okay, here k greater than 1, here n greater than 1. You always get a subsequence xn in A. Okay, such that, and the subsequence convergent. And this subsequence is convergent. Suppose it converges x. See. Okay. See, xn belongs to A and A is bounded, so we always get a subsequence xn k of xn such that xn k converges x by Boltzmann's theorem. I can write this by Boltzmann-Weierstrass theorem. Boltzmann-Weierstrass theorem. Okay. Every bounded sequence has a convergent subsequence. So xn is a bounded sequence, so it has a convergent subsequence. Now xn k converges x, right? Xn k converges x, you can write here as k tend to infinity. Now xn k converges x, but f is given continuous. Okay, so f of xn converges to f of x. Okay, from here I can write since xn k converges to x and f is continuous, it is given that f is continuous also. Okay, if xn k converges to x and f is continuous, so it imply f of xn k functional sequence f of xn k will converge to f of x. Okay, yes, k tend to infinity, right? I am writing in upper. So far what I have done this. We get a subsequence, this sequence xn k of xn, and this subsequence converges to x. Okay, and since f is continuous, then we can say s k tend to infinity. Since f is continuous, we can say f of xn k will converge to f of x, right? And this belongs to s k tend to infinity. Okay, since f is continuous, this always happen because we all know by this will happen by sequential clarity of continuity. Since x and k converts to x, then every subsequent converts to x will convert by sequential clarity of continuity. We can say this for any sequence converts to x and converts to x, f of x and converts to f of x. Okay, since f is continuous, by sequential character continuity we can say this. Now it implies f s and k, the sequence f s and k will be bounded, right? It implies that sequence f s and k, this sequence k greater than 1 will be bounded sequence, bounded sequence. Okay, bounded sequence. But this sequence is nothing but a subsequence. This sequence is nothing but a subsequence of this sequence. Okay, this sequence is nothing but a subsequence of this sequence, and this sequence is bounded. Okay, and from here this is true for natural number, right? This relation f s and k greater than n for natural number. From here you can write you place in place of n, you place nk. What you get? You get f of x and k will be greater than nk, right? F of x and k will be greater than nk. You get this. But if nk is still we know all know this, x and k is subsequence, so nk is still in natural number. So from here you can write nk greater than k. Okay, for k belongs to natural number. This result, this expression shows that f s and k will be unbounded. This subsequence, right? From here you can tell that this sequence f s and k will be unbounded, but you get here f s and k is bounded, so both contradict. Okay, you can say from this expression f s and k will be unbounded, since f s and k can be made greater than k. If you take limit in this expression s k tends to infinity, you get right hand side goes to infinity. Okay, since this is greater than k, so it is also tends to infinity, then you can say that also this limit of this also tends to infinity. So this sequence is unbounded. Okay, but in this we get f s and k bounded. The both statements are contradict. Okay, so you can say our assumption is wrong. What is assumption? Our assumption is f is unbounded. It is wrong. So what is true? What is correct? F is bounded. F is unbounded is wrong. So what is correct? Correct will be f is bounded. So if a is bounded, then f will be bounded. So option 4 is correct. And option 4 is nothing but a statement. If a is bounded, then f is bounded. Okay, so option 4 is correct. So in this question, correct option are 3 and 4. Okay. If you any doubt, you can always ask in the comment section, and more video solution will come in upcoming videos. So thank you.